Okay, class. Very good morning, class. Hello, class. Very good morning.
Morning,
Morning,
doctor.
doctor.
Uh, Class today will be our last class. With I believe that Dr. Lokahin have, he have done with his part, and today I will finish off the remaining, which is certified reference material. And before I start my class, okay, so I would like to discuss few things here. So, class, kindly please log in your attendance before 11 a.m. Okay, you have to log in before 11 a.m. One thing. Second thing, okay, we have another few more. Okay, and second thing, class, you have to basically make sure that you have okay, you have to make sure that you have submitted your assignment on control chat and you have done your quiz. Okay, so before I start our class, okay, after this class, I would like to talk personally to 3% from this group, class. Okay, Jos, Jivan, Peter, can you please PM me later after this class? Nur Liana Binti Tahal Hat, is it? Okay, kindly Nur Liana contact me and okay, Norliana, Jos Jivan Peter, and Chan Jin Hui. Chan Jin Hui, yeah. Okay, these three of you all kindly PM me personally. I need to discuss some things with you all. Okay, so class, that is one thing. Again, I'm reminding. Okay, for my part, I will only take. Take. This one is actually two things, class, which is your quiz, okay, and your assignment. And today, I have posted forum for you guys to answer the question, okay, on CRM. So class, today will be our last class, and as I announced before, so actually the day there is no changes, so we are continuing with the open book test. Okay, something like Dr. Kahin's part. Okay, mine also will be multiple choice questions. Okay, so at last I have decided not to give you any structure or make things complicated. So I'm going with the multiple choice questions. So class, kindly do revision. Okay, you must understand the content of the lecture. Then you will be fine. Okay, so that is the thing that I want to announce here. Okay, class. And I haven't give answer for your assignment. Okay, after this class, okay, I will discuss the answer here and I will upload the answer as well for your reference. Okay, so is that okay, class? Any questions here? If you are very shy to ask, you can always chat here. You can send message to me so that I can read for everyone. Is that okay, class? Okay,
Okay,
no
doctor.
response. Okay, so okay, class. In that case, okay, can we start our our last lecture for this semester? Okay, class. Now, okay, how many of y'all really know or have you ever heard about certified reference material? Okay, what is actually certified reference material? Class, when you are attached to the analytical laboratories or you are going to work in the analytical based laboratories in future, okay, for sure you will come across with the term, certified reference material, and you will use the certified reference material in your daily practices, okay, especially when you are doing your analysis. Okay, so class, now let's move on to the introduction. Okay, before we go into the certified reference material, I want you guys to understand what is the need for you to use the certified reference material in your analysis. So basically, class, as a chemist, what are the challenges that we are facing? Okay, we are so much attached to the ISO, okay, which is ISO 17025. All the laboratories have to follow the rules and regulation of ISO 17025. Okay, so and what are the challenges the chemists that we as a chemist that we are facing is actually the compliance, like how compliant the results are, and the decreasing in detection limits, okay, increasing number of compounds, is something like how, class, okay, when we are doing analysis, for example, okay, you are given a few cosmetic products, and your company want you to analyze all the cosmetic products, heavy metals in the cosmetic products, okay. So when you are analyzing that, you are using your SOP, am I right? So when you are analyzing using the proper SOP, class, okay, we might don't know the results that you are reporting is right or not, and the way you are following the SOP, because some people, if let's say we have three chemists in the laboratory, okay, in one laboratory, so the 3%, the way of the understanding of the 3% might have differ, okay, I'm sorry, I mean, it's a bit different, class, between the one person, they will understand the SOP in different way, another one person will understand the SOP in another way. So class, in order to make sure the analysis that you are conducting, the method that, in a way, okay, in a simple way, is actually the method that you are using is actually the right method, or the all the sample prep, whatever you are doing for the analysis is actually right, okay. How you can confirm that is by using the certified reference material. Actually, class, certified reference material is actually a real sample. For example, if you are using heavy metal analysis, if you're doing heavy metal analysis in cosmetic products, so the certified reference material will contain heavy metals, okay, samples, and they already mention how much is the concentration, okay. They will give you one certificate, okay. In that certificate, they will give you a very detailed information about the certified reference material, okay, including how they prepared, how much they spy, how much they validate the method, everything. It will be very clear, okay. So you can just include that when you are doing your analysis and check whether you are getting the true value that mentioned in the CRM bottle or not. So if you can able to get plus minus, class, if you can get that, that means the method and the procedure that you are doing is right, okay. That is the rules and regulation set by the ISO 17025. So most of the laboratories dealing with the real sample analysis, actually they are using the certified reference material, okay. It's a part of the accreditations and regulations of ISO 17025. Now, so let's move on to the challenges to analysts and the CRM manufacturers. So, class, actually, the CRM manufacturers will play a very important role. Okay, they should really produce a true certified reference material. So there is some criteria that there is a few criteria that the CRM manufacturers to follow. And basically, class, what are the challenges that we will face when we do analysis, okay, to get the accurate analysis, okay, what are the traceability, homogeneity, uncertainty, and error, how are we are going to define and measure. So class, when we are doing analysis, okay, analysis in a way is when we are doing our lab work, okay, when we are doing our lab work, class, sure got error, am I right? So how we are going to reduce the error and the contamination in the analysis, and what are the practices, procedures, or what are the things that what are the practices that we can do in order to reduce the error. So all these, class, we must think when we are doing when we are conducting a experiment. So now here, so class, accreditations, okay. So when we are talking about accreditation on the ISO and on the lab procedure methods and all those things, so it's actually we are referring to ISO 17025. Okay, now, so ISO and reference material. So class, actually ISO, under this ISO 17025, there is one guide called as guide number 34. Okay, which is, this guide is actually related to the certified reference material. Okay, so class, just give me a few seconds. Okay, just I need to check something. Just one moment, class. Okay, class. So when we are talking about the okay and ISO and reference materials, okay, class. So this ISO okay, so now class, ISO actually they started at 991, okay, the guide number 34, okay. So under this guide number 34, in ISO 17025, there is some general requirement for the competence of reference material procedures. So the latest revised in 2009, then finally 2000 is become ISO 17025 and reissued in 2007, and now the reissue and there is some latest ISO 17025. Okay, they just revised that. So class, basically under ISO 17025, okay, all the laboratories must demonstrate management system, technical competency, and technically valid results. So class, in order for you to produce a valid results, how you can convince your clients, okay, by providing a results of the or the analysis of certified reference material. By doing that, actually in a way you can you can convince the clients that the results, the method that you are doing is right. Okay, and apart from that, harmonization of standards and procedures. Okay, we must make sure the method that the procedure that we are doing is actually comply to the international standard and equivalent results among testing bodies and equivalent accreditation bodies in countries using international standard. So class, when we are using internationally recognized CRM in our method, actually it will be like comply to the international standard. That means the results can be valid everywhere. Okay, so that is the purpose that we have to use CRM. So class, and these are the thing, okay, ISO guide 34. So under this ISO guide 34, okay, actually class is something like this. Okay, ISO 9001 is the quality management system. Okay, ISO 17025 is actually testing and calibration laboratories. Okay, under this inside, okay, under ISO 17025 guide 34, which is CRM procedures and requirements for manufacturer of CRM. So guide number 34 will be talking about the CRM. So class here. So basically under ISO guide 34, okay, it allows transfer of results from CRM to labs for calibration of measuring equipments. We can evaluate or validate the measurements procedures. Okay, request CRM procedures, producers to demonstrate scientific and technical competence and ability to supply information about their materials. So class, basically here, okay, under the ISO guide 34, okay, CRM, according to the ISO guide, okay, they allow the transfer of results from CRM to labs. Okay, what are the purpose? We can use the results of CRM analysis. Okay, we can compare. Okay, the results of certified reference material with our procedure. In a way, it's evaluation or validation of the procedure method, or to calibrate the measuring equipment. We can check that. Okay, by testing with CRM. And another procedure is um, the CRM producers, okay, they must demonstrate. That means the company that produce CRM, they must come with the scientific and technical competence clearly with the certificate. They should able to provide all the information about the material, okay, especially about their traceability, uncertainty, everything, all the errors, whatever, it should be very clear. Okay, so now class, okay, let's move on to the standard. Okay, class, always in our laboratories during our experiment, okay, all our most of the lecturers or your lab tutor or lab assistant will mention, okay, use standard. Actually class, what is standard? Standard is actually a known to compare and unknown. It's something like how, class, standard is actually a concentration that we will prepare, a known concentration, okay, to compare with the unknown. That is the purpose of standard. Okay, so basically yeah, according to ISO definition, primary standard is actually always the highest metrological quality. That means their method is first class method. Okay. And secondary standard will be always the value will be assigned by the comparison with same quantity of primary standard. That means primary standard is considered of highest metrological quality. Okay. So class, here, what are the roles of standards here? So basically, we are using standard for ESD is external standard addition method, internal standard addition, and to calculate recovery uncertainty in order to do correction for uncertainty in process, calculate the measurement uncertainty, calibration, calculate recovery, find and eliminate error in the process. So for all these process class, we are using standards. Okay, so I believe that I won't explain much about uncertainty, and I believe that Dr. Lokahin have explained that in his lecture well. Okay, so class, let's move on to the reference material. So class, actually there is two things, reference material and certified reference material. Just that class, reference material is more simpler. Okay, the information is less information will be provided by the company compared to the CRM. CRM will have a proper, in terms of the traceability of the method, we can easily trace, okay, what type of method, how they produce the CRM and all those things. But when it comes to reference material, the information is a bit different. Okay, so ISO definition, okay, for reference material, a material or substance whose property values are sufficiently homogeneous and well established. That means class is sufficiently homogeneous. That means it's a really homogenized reference material, and we are using that for a calibration of apparatus, assessment of measured method, and for assigning values to materials. All these are the purpose of the reference material. Okay, what are the certified reference material? So class, here, a certified reference material is always accompanied by the certificate. Okay, and the certificate should have the very clear procedure that establish the material. Okay, in terms of traceability and uncertainty. Okay, and it should contain the supplementary information, for example, certifying bodies, methods of measurements, material preparation, statistical treatments of result. That means class, certified reference material is even more difficult to get. Okay, not all the analysis we can find CRM. Sometimes it's very difficult to get CRM for certain types of analysis. So here class, there are few types of reference materials here. Okay, so I have just introduced what is reference material, what is certified reference material. So class, here you must remember one thing. When we are talking about reference material, actually the materials should be, just one moment class, I think someone just came in. Oh no. Okay. Okay. So when we are talking about the reference material, okay, you must always know that it should be sufficiently homogeneous and well established. Okay, well, CRM, certified reference material, is basically one or more property values are certified by a procedure that establishes, okay, the traceability and uncertainty. That means class, traceability means that we can trace, okay, the methods, how they produce the CRM, okay, whatever that they are doing is right or not. Okay, they will provide you a proper certificate, and the certifying bodies who certify the CRM. Okay, that means class, even for the CRM manufacturers, they do have to follow ISO. So upon the manufacturing process finish, okay, so they have to call the ISOs auditors to come and certify the CRM, okay, to check whether what they are doing, what they have done is correct or not. Okay, so that they can supply to the chemist, okay, in order to include in their analysis. Okay, they can include in their analysis. Okay, class. So now let's move on to the types of reference materials. Okay, class, when we are talking about reference material, okay, there are few types of reference material. Okay, basically reference materials are used to support measurements which concern with the chemical composition, biological, clinical, physical, and engineering properties. Okay, and some commonly encountered type of reference materials are pure substance, which is characterized for chemical property or trace impurities. It can be standard solution and gas mixture, okay, often prepared gravimetrically from pure substance and used for calibration purposes. Matrix reference materials, which characterize for the composition of specified major, minor, or trace chemical constituents. Okay, and apart from that, physiochemical reference materials, okay, characterized for the properties such as melting point, viscosity, and optical density. Reference objects, okay, characterized for the functional properties such as taste, odor, and so on. So, class, these are the types of the reference materials. Okay, now let's move on to the classification of reference material. So, here, class, I have given a clear definition of certified reference materials and reference materials. So, class, when we are talking about the certified reference material must be come with the definition, okay, so that it can be traceable to an accurate realization of the unit in which the property values are expressed. That means, class, it can be traceable, okay, to a unit, okay, easily, okay. And while reference material are material, the property are sufficiently homogeneous and well established to be used for the calibration curve of apparatus, assessment of the measurement method, and for assigning values of materials. So, class, most of the method they will use reference material compared to certified reference material, because not easy to find certified reference material for certain types of analysis. It's only available for certain types of analysis. Most of the materials will be a reference materials lah. Okay, but you have to know the difference between these two. Okay, now here, class, reference materials again do not meet all the criterias. Okay, basically, class, reference materials, they do not meet all the criterias as for the certified reference material, which are more widely available. Okay, the principal difference is the additional evidence of metrological traceability and statement of measurement uncertainty provided on the certificate for certified reference material. So here, class, again, the reference material does not meet all the criteria, okay, as compared to the certified reference material, because in the certified reference material, the most important thing is they will provide you additional evidence of metrological traceability. That means how they produce, the method will be very clear, and the statement of measurements of uncertainty will be provided in the certificate. So, class, most of the ISO labs, they do prepare their in-house reference material, okay, just for the analysis purposes. But for the real auditing and for the real sample, especially when dealing with enforcement samples, okay, and all those things, they prefer to use certified reference material, okay, because certified reference material is actually a well recognized sample, okay. That means that we can use that as a comparison in our method to prove that what we are doing is right, okay. So and CRM is available for some methods, and not and sometimes it's difficult to get for some types of analysis. So if, let's say, you can't find CRM, then you have to go for RM, okay, reference material. So here, class, these are the example certificate of reference material. Okay, so the certificate, okay, will have all the information such as traceability, uncertainty, okay, this is CRM, uses of calibration, homogeneity, stability, certified values, and detailed supplement information. All these will be written clearly here. Okay, now traceability and stability for CRM, class. So when we are talking about traceability, to trace a product, okay, that is the meaning of traceability from origin to manufacture and to deliver receipt. We can do that. Okay, that's why it's under CRM. the traceability is one of the main component for the CRM. Okay, so for CRM, we must make sure that it can be traced up to the primary standard, from where the standard comes from. If let's say the standard origin from the another one standard, okay, they have to give all the information clearly. Okay, and stability class, CRM should not react during normal use. It should retain properties in expected time scale in the presence of expected condition. Okay, and unstable material, something like corrode, decompose, polymerize, burn. Okay, under it shouldn't be unstable material. Okay, stability is very important because when we purchase the CRM, we will keep that for few months in our laboratory. So it should be a non-reactive component or compound, okay, during the normal use. Okay, so that is the meaning of traceability and stability. Okay, and well class, for the reference material, okay, I have mentioned about homogeneity. So class, when we are talking about homogeneity, that means like uniform in composition or character. That means same. That means class, in bottle homogenization and between bottle homogenization, I mean homogeneity, sorry. So in bottle homogeneity is basically class, when we take a part for the analysis, the other part also should have the same property of the part that we took. Something like the whole bottle should have the same property. The solution should be homogeneous and it should be well redissolved into solution by instruction given on the material. Something like, they will say it's upon sonication or upon heating or upon shaking, all this material can dissolve in a solution. So all the solution should have the same properties. That is in bottle homogeneity. Between bottle homogeneity, that means between the multiple containers, they should behave same to the certain types of solution. So that is the homogeneity. So all these class, the properties for the reference material and certified reference materials. So class, now let's move on to the error and uncertainty. So class, what are the difference between error and uncertainty? So basically class, error is something that we can't estimate, while uncertainty actually we can estimate by using formula and calculation. Am I right? So that is the significant difference between error and uncertainty. So class, here, so identify all major uncertainty sources. Okay, and we should understand their effect on the analyte and its uncertainty. So when we are doing analysis class, what are the uncertainty that can contribute to our analysis? That means class, it can come from the solvent purity, it can come from the temperature, it can come from the volumetric flux, it can come from analytical balance. Okay, it can come from the syringe or pipette, it can come from so many factors can contribute for the to the uncertainty sources. Okay, now, so class, when we are using primary reference material, secondary reference material, and in-house or working reference material, actually class, when we are using primary reference material, the chances to get a very less uncertainty is very high. Okay, the more we use the more we go for secondary, sometimes we can't get the primary reference material, then we have to go for secondary reference material, or sometimes we can't even get secondary reference material for certain analyte. Okay, so we have to prepare our own reference material just for comparison. So all these class can introduce, okay, uncertainty or error in our analysis. So class, here I would like to conclude what are the uses of reference materials basically. It used for method validation and measurements of uncertainty, verification of the correct use of a method, okay, for calibration for purpose, and as for the quality control and quality assurance. So class, let's move on to the in-house preparation of reference materials. So class, most of the analytical laboratories, okay, they can't afford to buy certified reference material because it's very expensive. Certified reference material and reference material is very expensive, so they choose to produce their own reference materials. Okay, they might have some consider, some experts in the lab that can produce their own reference material. So when you are producing your own reference material, there are some keys that you have to consider. For example, selection of the materials. Okay, the native material. Okay, the material preparation, homogeneity testing, preparation and packaging. Okay, stability testing, certification studies. Okay, uncertainty estimation, and all those things that, how we are going to storage and how we are going to distribute, all these things that, we have to take into account when we are doing in-house preparation of reference materials. So class, I believe that you can even get more information in the ISO Guide 34, which is general requirement for competence of reference material procedures. Okay, for further information, you can always Google it out. The For more information about CRM. So, class, thank you for your kind attention. And do you have any question, class? We have someone just entered into the class. Okay, I have recorded the lecture, so I will upload in our Spectrum, so you may listen later, you may watch the recording later. Okay, class, another thing, kindly log in your attendance here, class. Okay, class, so far any question? Do we need to answer the questions? Okay, just one moment, class, I have one question. Do we, yes, class, yes. You have, do we need to answer the question posted? Yes. Class, kindly answer the questions on the Spectrum itself. It's a forum actually, okay? About your understanding on CRM and RM. Okay. So any more questions, class? Okay, if there is no question, okay, I will discuss the assignments. Okay. So class, here, as for the assignment, okay, so many questions, so many WhatsApps actually I received regarding this assignment. Actually, class, you must read carefully. Okay, the questions actually, they have given you the data. Okay, class, again here, I'm discussing the assignment here, class. Okay, the assignment, I'll just turn on my camera so that all of you will be with me. Okay, so here, class, uh, I am going to explain about the calculation question, okay, on control chart. Okay, here, class, I have given the data. One is the control data, another one is the experimental data. Okay, and the question asks you to construct the X bar chart and R chart for your results. So class, here, in order to plot a X bar chart, okay, you should find the X bar chart formula. But here in this case, we don't have the standard deviation, we don't have the value, the limit value. Am I right, class? So in that case, we still can go with the X bar chart. We should plot X bar chart, but we must use alternative formula. Okay, alternative formula. That is one thing. Second thing, class, you have to, no, most of y'all are confused because you have two sets of data. Okay, one is the experimental data, sorry, one is the control data, and another one is the experimental data. So here, class, I would like to clarify. Basically, the control data is for you to calculate your central limit, upper control limit, and lower control limit. It's just as the kind of, it's a control data. It's just to evaluate our data, whether our data is within the control data or it's moving far from the control data. The experimental data, actually, we have to find average and plot on the calibration curve. Sorry, in the control chart, we have to plot all the data, okay, the experimental data by calculating the average, okay, for X chart and the range for the R chart, and we have to use the data 1 to 24. Okay, we have 24 data. We have to plot in the control chart. Okay, that is how we have to do this uh, this question. Okay, class, now, so as for the x chart, x bar chart, okay, as for the x bar chart class, so what we can do here is actually the formula is for upper control limit and lower control limit. So I will use this formula, alternative formula. While for the lower control limit, mean, class, this is mean, minus A2 factor over RA. So here, class, what are the value of RA that we can obtain here is actually, class, RA, you know how to find or not, class? RA is actually range. We have to minus, no, it's from the control data. Okay, we have to find the range for each point and we have to calculate the average for the range. So range for this question is 0.12 and A2 factor for sample size 24, okay, is actually 0.73. And the mean by using the control data, you will get 7.01. So class, basically UCL and okay, UCL is actually 7.01 plus 0.73, 0.12. So we will get about 7.098, and for LCL will be 7.01 minus 0.73 times with 0.12. Sorry, class, the okay, it will be about 6.922. Okay, so and your central line will be your same as this is your central line. So your CL for this will be 7.01. Sorry, 7.01. Okay, your CL will be 7.01. So class, again, class, don't get confused with this data. This is range you can get from the control data. Okay, so basically, class, to calculate all this value, you must use control data. Okay, in order to plot X bar chart here, we are using alternative formula because the question doesn't give you the limit. Remember that, class, just go and refer to my slide, my lecture notes. Okay, you will get the idea. So the 0.71 is actually, we have 1 to 24 here, class. Okay, I'm just showing you the thing. Okay, we have number, okay, we have 24 samples. Okay, and we have to find the average here. So the average is actually for the, this is the X average and this is the range. Range is actually biggest value minus smallest value. So finally we find the average here, average. So here the RA is actually 0.12. I just use this value 0.12 here. So class, here the A2 factor is actually 0.73. You can refer to the, just one moment, class. I'll give you the, I think the table is, um, okay, if you refer to my lecture notes, okay, you can find the value for the sample. Okay, we have 24 samples here, so we have to find, okay, the A2 factor. Okay, the sample size is actually how many sample size? So the A2 factor is actually 0.73 for this question. Okay, so you can go and refer to my lecture notes, class. Class, so far any question on X bar chart? Okay, let me check, got any question or not? Uh, okay, doctor, I'm not sure how to reply to the forum because it seems like I can't reply. To answer the CRM or RM question posted. Okay, class, you have to answer. Okay, just answer the questions. Okay, can you all answer the questions? Okay, just class, just one moment. I will. So class, these are the control chart slide for the control chart. So here you can okay, you can just one moment, class. I just want to show you all the table. Okay, in case if anyone here miss our first lecture, okay, the table is here, class. Okay, so 0.73. Okay, I'm using 0.73, sample size 4. So class, for this question, okay, we have how many data control chart data? We have four data here. So the sample size is actually 4. That's why I'm taking 0.73. Okay, don't get confused, class. Okay, because some of y'all ask about that, are we going to use 24 or 4? Actually, you have to use the number of samples. Okay, for this way, class, not this way. Okay, don't get confused. So that's why here I took 0.73. Okay, so now we have done with the just one moment, class. We have done with the X chart. Okay, let's me move on to the R chart. Okay, class. So as for the R chart, okay, so how we are going to do R chart? Okay, here, class, for the R chart, UCL, sorry, UCL and LCL. So UCL is equal to D4RA and LCL is equal to D3RA. D3RA. Okay, so here, class, so our n is equal to 4. Okay, the sample is actually we have for each sample number 1 we have 4 data. So our n is equal to 4. So for n equals to 4, okay, again, class, for n is equal to 4, the okay, this is for the control chart for R range. If let's say n is equal to 4, okay, the A for alternative X chart is actually 0.73, and for n equals to 4, D3 is 0, and D3 it's actually 0 on class. D3 is 0 and D4 is actually 2.28. 2.28. So D4 is actually 2.28 and D3 is actually 0. So must use this value, class. Our D4, I mean, n equals to 4. So we have D3 value here, D4 value here. D3 is 0, D4 is 2.28. So here, D4 is actually 2.28 2.28 times with 0.12, which is equivalent to 0.2734 or 0.27, roughly around here. And as for the LCL, class, since D3 is 0 and 0.12, so we will get answer is 0. Okay, so and so this is for our LCL and sorry, our UCL and LCL. So how about the central limit, class? So our central limit for the R chart, okay, will be same as this value. Okay, this value, which is our central limit, will be 0.12. Okay, so our RA, that means our central limit will be just RA. Okay, RA is actually the range, which is 0.12. So these are the calculations. Okay, the answers, class, for the control chart. So class, so far any question on control chart, class? I believe that all of you all understand the calculation of control chart. Okay, so just one moment, class. I cannot answer in the spectrum. Doctor, do you need to change your share screen because we are still seeing the PPT slides? Oh, class, you can't see the whiteboard. Can you all see the whiteboard, class? Oh, I think something is wrong. No, oh my God. Okay, class, just one moment, just one moment. Okay, class, I think let me change the setting in the spectrum and we can settle this. Okay, the forum, just hold on first, class. Probably something wrong with the setting. I'll just go and check the setting so that you all can start to post the answers for the question. Okay, just hold on first, class. I'll just check what is the why you can't see the whiteboard, my Microsoft whiteboard. Okay, class. Y'all can check can see the Microsoft whiteboard or not, class? And it's still on the no. Oh, something wrong. Okay. Okay, how about this class? Can no. Okay. So class, it's okay. I think it's difficult here. Never mind, class. Class. Regarding the control chart, you all can understand roughly about the assignments, right? You all still have any questions on the assignment? Okay, I will upload the answers now. Okay, kindly have a look. If you have any question, you can always ask me. Okay, because I have done the calculation here via the whiteboard, but I don't know. I can't share that. Okay, probably I need to play around with the setting. I think okay. Oh, class. Okay, let me try again. Just one moment, class. Okay, class. Yes, class. Now you all uh, can view the whiteboard. Okay, great. Okay, so now class. Okay, these are the calculation that I have mentioned here. Okay, never mind. I can just go again. Okay, one more time. So here, class. This is the calculation for the R chart. Okay, never mind. I'll just create another one. Okay, it's just a fast one, class. I'll do. So as for the control chart, okay, to find the calculation for the given assignment, okay, for the X bar chart, okay, we have to use for the UCL, sorry, for UCL and LCL. So the formula for upper control limit, okay, we use mean, okay, plus A2 factor, R, sorry, RA. This is the range. And this one is X mean minus A2 factor RA. Okay, so here class, the mean is from the control data. Okay, it's about 7.01. Okay, again here class, the A2 factor is 0.73 for sample number 4, n equals to 4, and the range, the mean of the range for the control data is actually 0.12. So total 0.70, sorry, 7.098. As for the LCL, it will be 7.01 minus 0.73 times with 0.12, so which is equivalent to 6.922, and our central line will be same as the mean. Okay, mean which is equal to 7.01. Okay, so class here, okay, this is 7.01. Okay, so I'll just go just one moment, class. Okay. So we have to you have to refer my slide notes, class. So on the control chart, okay, in the table, actually, when n equals to 4, your A2 factor is actually 0.73. So why is n equals to 4? Is n equals to 4 is because the sample, each sample have only 4 data. Okay, you have to see the sample is this way. Okay, so the n is equal to 4 for the X bar chart. Okay, is that clear, class? And the R, this R value is actually, class, don't get confused. This R is actually from the experimental data. We have to calculate the range. That means highest value minus lowest value, the average of it. Okay, now for the X bar chart, we are using alternative way. Okay, let's move on to the R bar chart. Okay, so class, R bar chart, for this question, uh, how we can calculate um, things is actually by using this formula. So here, class, okay, you can use sorry, you can okay, you can use this formula, okay, which is UCL D4 RA D3 RA LCL. So here, class, D4 value and D3 value, okay, when n equals to 4, D4 value is 2.28, and when n equals to 4, again in the chart given is D3 is actually 0. So your LCL will be 0 and your central line will be 0.12, which is your RA value. Okay, so by this way, class, actually you can calculate your upper control limit, lower control limit, and central line for your R bar chart. Okay, so once you have plotted, then you can use your experimental data. Okay, again your experimental. So you just have to find the average, that means mean, here for the X bar chart and for the R chart, so that you can start to plot in the control chart. Okay, so I will upload the answers here, class. So again, class, this will be our last class. So next week will be your revision week. Probably you can start to do your revision early, so that you won't do a last minute revision. And my question will be all multiple choice question. That means it can be true false question also, and it can be multiple choice like A, B, C, something like that. Okay. So class, kindly start your revision early, and please answer my questions. Okay, how many questions? Okay, for my part, I will have 35 questions. Okay, 35 questions for my part, and I will cover everything, class, whatever that I have taught you all so far. Okay, you may recall back all the theories, and some calculation involving control chart also will be there. Okay, you must know how to calculate, especially X bar chart and R chart. Okay, it's very important. And what else you have to know is actually basically the definition. Sometimes, class, I don't ask exactly like, you have to memorize. Sometimes you have to use your common sense to answer. Okay, the true false questions, I have few true false questions. Then I do have a multiple choice questions. Okay, so I will conduct the exam via Spectrum. Okay, so maybe one day before the exam, I'll brief the procedure, how to log in and all those things, class. Okay, so with that, class, thank you so much. Thanks for your cooperation, and kindly, I need to meet this 3 person. Okay, Chan Jin Hui, Jos Jeevan Peter, Nur Liana Muhammad Talha, is it? Thal, Talha. Okay, kindly PM me personally. I need to discuss some things here. Class, again, okay, kindly log in your attendance. Okay, your attendance is very important. Any more questions, class? Any questions so far? Okay, class, with that, thank you so much. All the best for your finals. Okay, don't worry much, class. The questions, you can answer. It's something like your quiz. Okay, so don't worry much. Okay, try to recall your quiz questions as well. Okay, so with that, thank you so much. All the best, and I hope everyone can score well. Okay, in this semester, QAQC. Thank you, class.